Okay, here are the guided note proofs for 4-5. If you notice immediately, this first picture has been redrawn. You may want to take a moment to just pause the video and redraw that picture. The first one's not going to work for you. Now, in these quadrilateral proofs, we're finding that our given information has so many options that our original strategy from chapter 3 about starting with the given, figuring out our first step, doesn't really work anymore. Instead, this time it works a lot better if we work our proofs backwards. If we look at where we want to end up, so for example, I want to say that angle A is equal to angle E. Once I know where I want to go, it seems a lot more clear that given that BCD is a rhombus and BA equals CE, I'm probably going to be dealing with something about either the opposite angles of a rhombus being equal or deal with their parallel lines giving me equal angles property. It kind of helps trim down what options I'm going to go with. So let's go ahead and start with our given information. Get that on our T-chart. And we're going to start with BCDA is a rhombus, and BA equals CE. And that's our given. Now, I've marked my picture. That is a super important step. Now, in looking at this picture, this guy out here has an intriguing look to me. I think I can get somewhere with that. So I'm going to go ahead and try to prove that that's an isosceles triangle, because I know that BA equals BC, which equals CD, which equals DA by definition of rhombus. Now, why did that help me? Well, BA, all the sides are equal. BA has a single slash, single slash, single slash. Now I do know that this triangle out here in the green is isosceles. What's true about the base angles of an isosceles triangle? Well, they're equal. So angle E is equal to angle CDE, and I do have to use 3 there because there are many angle Ds, and that is by the isosceles triangle theorem. Now, why does that help me? If you go back, and remember, one of the things we're always going to be looking for is, can I make that substitution? These lines right here are parallel. And that gives me something intriguing to think about those two angles. If this is a transversal. So what I'm going to say is I'm going to say that BA is parallel to CD, and that is actually definition of parallelogram. Some proofs would have you say that the rhombus is a parallelogram first and go through that. I'm okay with kind of skipping that step. We have our family tree. We know that a rhombus is a parallelogram, so we're good to go. Now, by saying that, then I can say that angle A is equal to angle CDE because parallel implies corresponding angles are equal. And then if I look, I've got E equals CDE, and I've got A equals CDE, and that means that angle E is equal to angle A by substitution. And that completes that proof. Now we'll go on to the next one. We're actually going to skip this proof. It shows up as a homework proof. I'll give you a little bit of a hint, though, to get you started. If V, P, Q, Y is a rectangle, you know you have right angles, you know you have opposite sides equal, you know you have parallel, and if you want to ultimately prove this little guy is a rectangle, I think you can fairly easily see through your parallel lines, through your right angles, that you can get there. So we're going to move on to the next one, where we have that angle 3 is supplementary to angle 2, and angle B equals angle 3, and we want to prove ABCD is a parallelogram. So when I'm thinking this one backwards, I've got those 5 proof of parallelogram options. And those are some of the things, I'm not going to use those, but those are some of the things I'm going to look for. How can I prove it is a parallelogram? Can I prove sides parallel so I can have it by definition? Can I prove any of those criteria in order to say it's a parallelogram? So let's start with our given and get our picture marked. Now, 3 and 2 being supplementary, I can't really mark on my picture, but I am going to use those in my given. But I can mark that B is equal to 3. So I'm going to write angle 3 is supplementary to angle 2, and angle B equals angle 3, and that's given. I'm also going to take, and I'm going to mark A, B, C, D. I'm going to outline what I'm after in yellow so it kind of stands out to me. So the first thing I'm probably going to say when I see 3 and B being equal, again, despite what the picture looks like, if I think about this line right here, and I think about this line right here, and I look at this, it appears to me that I have alternate interior angles, which does let me say that AD is parallel to BC because alternate interior angles imply parallel. So again, no matter what it looks like, if the information holds, that's what we go with. So now I have one pair of parallel lines. I either need to prove them equal, parallel and equal gives me a parallelogram, or I need to prove that the other pair, AB and DC, are parallel. So let's see if we can figure out a way to do that. So one of the things that I see I have here is I have the ability to take my given and write an equation. If 3 and 2 are supplementary, then this equation is true. And remember, we always want to go from words to equations, and that is true by the definition of supplementary. Now, did that get me anywhere? Well, if I want to prove that AB is parallel to CD, I'm looking for one of my parallel line angles. I'm looking for corresponding, I'm looking for alternate interior, I'm looking for same side supplementary. Well, given this picture, I either have corresponding in 3 and 2, corresponding in 4 and 2, or I have same side interior with 1 and 4. So there are 2 different ways to do this. Since I'm given the supplementary bit, I'm probably going to head in that direction and see where it takes me. So one of the things that I can write is that these 2 up here make a linear pair. So I can say angle 3 plus angle 4 equals 180. and that is by the linear pair theorem. Now, as always, if I have two things that equal the same, that means those two sums are the same. So I can go ahead and write that angle 3 plus angle 2 is equal to angle 3 plus angle 4. That's by substitution. Now I have that same angle 3 value on both sides. So after we do the substitution, one of our common next steps is to subtract from both sides. So I subtract angle 3 from both sides. And when I do that, I'm going to go ahead and mark that angle 2 is equal to angle 4. Well, in relation to A, B, and DC, 2 and 4 are corresponding, so I can say that AB is parallel to DC because corresponding implies parallel. And once I mark that on my picture, it's clear that I now have A, B, C, D is a parallelogram, and that is by definition of parallelogram. Part 2 will do the next two proofs.